Hey, it's Jim Bergman with measureQuick. We got a new workflow built into the gas heating app. It's called the gas service workflow, and it's really pretty slick. It has a full photo documentation section, as well as it does a diagnostic report that attaches to the main report, more or less doing all of the qualitative analysis of the report to tell you what's wrong with the system, if it's a pass or a fail. And I want to walk you through that process. It's pretty slick. I've got a couple of tools here. I just want to show you what I've got going here. I've got a combustion analyzer here, the AccuTools Blue Flame. I've got this zeroed already. I zeroed it outside. You got to make sure you're zeroing your combustion analyzer in fresh air. And then I've got a couple of field piece manometers I'm going to use for supply and return. I've got 3 testo manometers. I'm going to use one for my manifold pressure, one for my combustion blower, and one for my incoming gas pressure. I've got a supply air probe, I've got a return air probe, I've got a combustible gas leak detector, a couple of redfish meters, and a ambient CO meter, and a printer. And it looks like a lot of tools. When we get all this hooked up, you're going to look like, my gosh, this looks like a Frankenstein project. But it's really quite slick because it allows you to get the work done very, very quickly. You don't have to start and stop the furnace constantly to get things going. So the first thing you want to do whenever you're working on any kind of combustion appliance, visual inspection trumps everything. Right? And that's really what this is, a big visual inspection. So before you dive into work, taking off panels and things like that, I'm going to go ahead and turn this furnace on. I had it shut off for a minute here. I got a broken switch here. I snapped it by accident. I'm going to turn my gas back on here just because I had some things apart earlier. And I'm going to go ahead and turn the thermostat up, and we're going to get a call for heat going here. And what you want to do is you want to actually do an initial test-in combustion test. We want to make sure that the furnace is not producing massive amounts of CO, the numbers look decent. It just takes a second to do this. We're just going to do just a quick screening of some things and make sure that things look good. While the furnace is starting, I'm going to just take a quick peek at the filters here. The filter looks pretty new on this. I changed it a couple months ago. I did add a secondary filter here on the side. One of the things that I found out was that that my filtering, even though I have a 16 by 25 here, on the heating airflow, it was actually far exceeding my filter face velocity number, which means basically, even though these are 4-inch filters, I was running too much air through them too fast. And what that's going to do is it's going to result in poor filtration. And after I actually did this and added this second return, and I made this boot so it's all removable, so you can just pop these couple slips off, pull this whole fitting out, and get into the blower if you have to. So it looks like it's not very serviceable, but it is. And after I built this out like this, what this allowed me to do was get the dust levels way, way down in my home. And it was a huge improvement for not too much money to add this little boot in here. So the appliance is fired up, and all I'm going to do here is I'm going to pull my plug, and I'm going to put my probe in the stack here. And then we'll just go ahead and we're just going to do a quick pre-screening. And I'm not even going to really catch this on my measureQuick app yet. All I'm doing here is just making sure that my CO numbers look reasonable, my combustion numbers look reasonable. Before I go getting into the appliance and making adjustments on it, I just want to have just a starting point on this of where we're at. So right now we're up to about 40 ppm of CO. We're just going to let that run till it stabilizes, and then we'll, then I'll go ahead and start getting the rest of the tools set up. All right, so you can see we've stabilized now. We're at 46 parts per million and 8% O2 on there, 69% excess air. Again, the numbers look all reasonable here. I'll just scroll through a couple readings here so we can see them. My stack temperature, my draft, efficiency, net and gross look good. And then I'm going to just take a look at the rest of the readings, see everything else here I want to look at, and I think we're good. So this is just set up with a couple numbers on here, but primarily what I wanted to look at is make sure I'm not making excessive amounts of CO, and those numbers are good. So now that we got that set up here, I'm going to go ahead and turn the call back down, and I actually, we're going to end the call for heat here, and then I'm going to go ahead and start taking some things apart, and we'll do an inspection. You want to let the furnace cool down naturally. You just don't want to kill the switch, because I might have to turn it down a little bit further here. It's convenient having a thermostat right outside my door. One of the things that we can do now with these thermostats is obviously they have remote sensors depending on the stats you got. So I have a thermostat on here with 2 remote sensors, so I can put the thermostat down in the basement. I've got a wood ceiling in my basement down here, and I can't really reroute the thermostat wire easily, so the remote sensors was a really easy way to go. And now this thing's cooling off here. We'll go ahead and let that finish cooling down, and then we're probably cool enough here, and then we'll do a quick inspection here. So what I want to do, and a couple things I'll show you here is I got set up preliminarily. I have the videographer come over to the other side of me here. All right, so this furnace has this is a full modulation furnace, but what it's got a test mode here, and I set the dip switches up so that it's got 100% call for heat for 60 minutes. So it's a really handy thing when you're trying to get the furnace set up, just to set it into a test mode. I can check my blower, make sure my blower's good and clean. I inspect these hoses here on the traps. These, a lot of times, will get corroded, so you want to just give everything a little bit of tug and pull and make sure everything's still connected nicely. Look for evidence of water leakage down in the bottom of the furnace, which there doesn't appear to be any. Then another thing I do, this is an ECM motor, and if you look at the wiring diagram here, I don't know if you can get in close on that, but basically this is the hot wire coming in, and it goes through a choke, and then it feeds into the blower motor. So what I did here, in order to get blower watt draw here, is I just cut the wire, add a little black wire, and I fed this through the plastic grommet on the side. So I can measure amps of my blower here with the door on, and then I'll just pull this back inside when I'm done with it and rewire nut the two wires together. But you really can't make a blower amperage reading with the door off, and plus it depressurizes your combustion air zone, has some other issues. So most of the readings we're going to make can be made on the top side of the furnace. I always go through and just tug on my thermostat wires, make sure everything's snug on the stat wires. Everything looks good there. You know, circuit board, Molex plugs, just make sure things are tight. Most of the time when you have a problem with a furnace, it's just due to loose connections or things like that. So we want to make sure that all that is done. And now all that looks pretty good on there. So we'll go ahead and we'll button this bottom door back up. And we're going to go ahead and get the top side ready for some measurements here. All right, so we got the blower door back on, and now we just want to do a quick little gas leak detection on here. This is the AccuTools EL320. It's a really inexpensive gas leak detector. It is intrinsically safe, and you can see it on the back of the label here. What that means is it's a lot, you can use it in an explosive area. It's safe for that type of an application. When you turn this thing on, it's got two sensitivity modes. If you tap it twice, you'll hear it wind up or wind down. So when it winds up, it's on high sensitivity, and down, it's on the low sensitivity. So I'll put it on high sensitivity here. I'm going to show you, the furnace has been off for a few minutes, but there is natural gas that's in this manifold. When the gas valve shuts, there's no place for this gas to go, and it will slowly leak out. And I'll put this up here, see if we pick up a little gas there. And you can see we're still picking up gas, and you'd think maybe your gas valve's leaking, but it likely is not. It's just the sensitivity of this is so high that it picks up any gas in the area. If I put it on a lower sensitivity and test it again here, you can see it's not picking that up anymore. So sensitivity on these things is just ridiculous, and it's picking up a couple little ticks there, but it is ridiculously high. And so we usually test on high, and then if we find we have a leak, then we're gonna check with soap bubbles on low. So I'm gonna turn this back to high for a second. I'm gonna go around my fittings here and just sniff for gas leaks. You want to move this about an inch a second or so. And we would just test the entire gas line with the gas on and make sure that we don't have any leaks, which all this looks pretty good. And you can test obviously all the way back through and get the entire line tested. And I typically test mine once a year, and it's all solid all the time. So now that we got the gas leak detection done, we made sure there's nothing wrong with the furnace, we're going to go through and we're going to actually hook up the manometers. So I'm going to shut the gas off here because I'm going to hook up to the incoming gas pressure. So I'm going to go ahead and back the incoming plug out. And again, you got to have the gas pressure off on this one because it is a, this one here's for my pressure switch. And this will be incoming gas pressure. Now, I put a clip on a lot of these. If I have to ever zero my manometer, all I do is just take this little binder clip and I grab the hose, and I can pinch it off. And then I can take my manometer off and zero it. and open the hose right back up again. So it's handy if you need to re-zero your manometers or test your zero on there to do that. We'll just get this threaded in here. And we'll get the hose untangled a little bit. We're going to go ahead and put this in the front of the furnace. I've got my next manometer here, which is my manifold pressure. Same thing here. There's a plug in a gas valve here, but Rheem also makes one here for the manifold itself. So go ahead and we'll pull that out. We're going to hook up to the manifold. And we'll let that guy sit here. Then I've got my induced draft pressure here. And what I'm doing here is just testing the induced draft pressure that the inducer will pull. So I'm pulling this off, slipping this tube over this fitting here so I have a nice seal. And then I'm going to slip in this tube back onto the port of the induced draft motor. And what this is going to do is allow me to measure the pressure that's developed by the induced draft motor. So you can see that's hooked up down here. And I've got my 3 manometers hooked up now. I'm also going to measure my return air static pressure and supply air static pressure. So I'm going to go ahead and turn these on, and I have a hole that I drilled over here, and I bumped my CO meter. We don't have CO in the room. I just hit the little test button there with my hand. And then I'm going to get one in the supply duct here, and I'm going to actually physically measure in my supply this time. You can measure, if you really want to get a total external, we'll measure it here just to get total external static pressure. And I've got a hole drilled here. This is a tricky situation here where I've got no place I can drill a hole behind the coil here. And I needed a place to get in and make a static pressure reading, so I popped the hole here, and this will get me in by the, in near the heat exchanger, and I just position that probe so I get it out of the path of the heat exchanger. You can see that arrow's pointed up, which means that it's in line with flow. Okay, so now I'm measuring my true supply air static. We'll get this one turned on. All right, and flashing. And then I've got a return air temperature sensor. Just going to stick this over here in my return air. And then I've got a supply air temperature sensor here. Testo 905i is the one you really want to have for this. This is a K-type thermocouple, which means it's a lot higher temperature rated. And for supply air, that's what you want to use. The field piece and the Testo, the humidity sensors, are rated at 140 degrees, which for a lot of humidity sensors is it's too low for a furnace. But the other thing is that in that hot air, it dries the humidity sensor out and it'll compromise your accuracy. So you really should go with a Testo 905i for that. We're going to go ahead and we'll stick that up here. In the supply duct, I put a little magnet on mine to make it stick in there. And now we've got everything sort of paired up and ready to go. Let me grab my phone here, and I'm going to go ahead and we'll hook everything up to measureQuick and we'll get started. All right, so I've got all my Bluetooth probes turned on here. Nothing's really connected yet. I'm going to go in my toolbox, turn on field piece, turn on my Testo Smart probes, and I'm going to connect to my Blue Flame analyzer. And what I'm going to do here, again, I zeroed this out into the space already, so I know I have no ambient CO here. But we're going to go ahead and do the testing now. And the first thing you're going to want to do here is you're going to go into temperature pressures and go into, well, let's start with the project actually. So we're going to go to project. We're going to go to the gas furnace heating service. I'll tap on that. I'm going to use COD data. This is a huge reason you want to use COD data is because you don't have to re-enter everything every time you come in. So it's going out now searching for the site, and we'll give this a second here. I think my grandson's up on our Wi-Fi up there. Let me get off our Wi-Fi for a minute, see if there we go. And we pull in site 69, which is the house here. So here's site 69. It's going to pull up the model number of the air conditioning unit. I'm going to go ahead and select that. I'm going to start the project. And then you'll see that the house has already been geotagged. So you can see the geotag location. And we can see our profiles already entered. So this is 90 plus natural gas furnace, 94% efficient. It's got a minimum supply pressure of 5, max is 10.5, rated 3.5 inches of manifold pressure, pressure switches, and that's the high pressure switch is 1.5 inches. Temperature rise is 40 to 70. Total external static pressure is rated at ½ inch. So everything there is good to go. We're going to hit submit. And our filter information, the last time I changed the filters was 6/30/2020, so that's still good. I'm going to leave that there. I have two 16 by 25 by 4s, 40% pleated filters. I'll hit submit. And you guys saw me inspect those earlier. And now we get into the photo documentation section. And this is where we just would document a couple things here. So I'm going to go ahead and sneak past you here. And let me get a level here. And this is just a good opportunity to, take some photos of things. So if you want to show that your thermostat's level, we'll hit camera and we'll grab a photo of the thermostat that's level, hit use photo. We can get electrical system here, camera. I'm going to show this light switch here that's broken. This would need to be replaced. So we'll get a picture of that. We'll use the photo. Air distribution system is the duct system. And again, it's just if you're finding any problems or if you want to take a picture in general of your air distribution system. Photos tell a lot. And air filtration system, we can show condition of the filters here. So let me just move this out of the way for a second. If we wanted to get a quick picture of the filter condition, we use the photo. And one of the things here, you'll notice that too, is you want to make sure that your filters are blocked off. You can see here I put a piece of cardboard here with some foam tape on here to lock this filter in. Also on the back of this door, I've got a foam seal on here to make sure that air's not going around my filter. Air bypassing your filter is a big problem. You want to make sure these doors are sealed and locked on there because you don't want to depressurize your combustion air zone. Condensate drain, again, I'll get a picture here of our condensate drain system. Use that photo. On the combustion air zone, this is an area here where we got to look at this a little bit closely. We have a pretty small space here, and we also have behind here, come on in here for just a second. We also have behind here a natural draft appliance, a hot water tank. So, don't miss things like this. The door's open, you don't think about, here's a hot water tank behind here, and we need to make sure this atmospheric appliance, by the time we're all done, is drafting properly, and there's no like return air leaks or anything else that's going to overcome this natural draft appliance. So the other thing we want to do here, and here's a big pet peeve of mine, and it's even in my own house, is chemicals near the combustion air zone. Now, my wife keeps most of this stuff closed up. You can see we have our detergent inside of a jar there. She keeps closed. The Ziploc bags are closed. All these things are capped. But, the washer and dryer are very common in these types of areas, and you don't want these chemicals to get pulled into your furnace because they will wreak havoc on making the heat exchanger rot out early. This is a condensing furnace, and when it pulls through all those chemicals through there and they condense, they make acids, and those acids get in the bottom and they'll actually rot the heat exchanger out. So you want to make sure you keep your CAS is free of chemicals, or make sure things are capped or tight, or put them in a laundry tub, something to keep them from bothering the CAS zone. So I would document this like I'm doing in my own house, so I can tell my wife later that she's still got stuff in our CAS. Heat exchanger, I'm going to go ahead and we're going to fire the furnace up here, and we're going to take a look at a couple things. On the heat exchanger, the one thing we want to do is, first of all, a basic visual inspection, which I'll just pop my camera up here and see or my flashlight. You can see there's almost no visibility in this heat exchanger here. So what we really want to watch for is we want to watch and make sure there's no flame disruption when the appliance starts, and we want to do a test for, I got to wait for my thermostat to wake up here. We got to do a test in the airstream in the ambient air for CO, the return air, and the supply air for CO. And this all comes from the we'll turn it up to 75. This all comes from the AHRI manual here. So when this furnace lights off, I'm going to watch my burner, and obviously my blower's not started yet, so when I hear my blower come on, I want to make sure that flame is stable. And I might get a picture here of just the condition of the flame, just to document that as I go. So we'll let that light, and we'll go ahead and we'll get that photo. So all my manometers are up and connected. Everything's sort of in standby here till we get the furnace running, and we're going to run through the full test here in just a second. We'll get this wrapped up. Turn the gas on, that always helps. And now we're going to go ahead and I'm just going to zoom in here. I can get a good picture of the flame, and I can see if I look at all these flames that they look really, really nice. It's smooth, and we'll hear the blower kick on in a minute. And what we're watching for is any kind of flame disruption indicating a heat exchanger breach in there. And so as soon as that blower starts, which I believe is starting, hasn't quite started yet here, we'll let it get to a warm up here, and there it's starting just now. ECMs are hard to hear. And then go ahead and look in here. You can take a look at the camera, and you can see the flame in there looks really nice and smooth. Go ahead and get in there a little closer if you can, so you can get a good look at that. And what we're looking for again is flame disruption, and in this case here, that looks really good on the appliance. So we'll use that photo. And then any other equipment we want to take, venting on these is probably one of the most important things. Look at your vent system. Make sure that the vent is, I'll plug this one standing here. Make sure that the vent doesn't have excessive elbows. So I got 1, 2, 3, 4, 5 elbows, and I'll consult my manufacturer's guide to make sure that vent's right. Down here at the end, at the top, this is called an exhaust accelerator, and you need to make sure if your appliance requires this that is on there. That exhaust accelerator just necks down the pipe so that it speeds up the flue gases going out of the furnace to get them away from the house. So that all looks good on there, and we're going to go ahead and cancel this photo, and might go outside and take one more image out there. We'll hit submit, and you can add images anytime you want during the test. So now we're at the test system here. I'm going to hit ambient CO inspection, and again I'm going to go ahead and activate my combustion analyzer. And what you'll notice is that it's going to show 0 ppm ambient on here, and I'm going to hit capture. So now I'm going to activate my return, and you need to give this a couple seconds here in the return air, probably about a good minute or so. And what you're waiting for is to see if there's any carbon monoxide. And you're going, well, there's no CO in the air. Where else would I get it from? Well, if you're in California, you got a lot of attached garages, and you can have ductwork run through a garage. You can have other areas that produce CO, and you can pick up CO in a duct where you may not pick it up necessarily right where you're standing. So again, I have no CO in the return air. I'm going to hit capture on that, and I'm going to activate it again, and I'm going to move it up to supply air here. And we're going to give this a good minute or so in the supply air to make sure we're not picking up any CO in the supply. And this is, if we know we have a small amount of CO being produced by the furnace, and if there's any breach in the heat exchanger in any way that flue gas is getting into the airstream here, we'll pick that up. Now it's really important to use a combustion analyzer to do this test. You do not want to use a standard CO meter, because a lot of them are not temperature compensated. And when you get the hot air in here and it changes the temperature of the meter, it could give you false CO on there. And again, this is good, so I'm going to hit capture, and I'm going to hit submit, and now I've got my ambient CO measurements in here. Now, as far as my pressures go here, I've got my inlet pressure, my manifold pressure, my induced draft pressure, return air, supply air, static. All that data is coming in. It looks good. I'm going to hit submit on this. Gas, now we're going to go out and clock the meter real quick. Now, heat content of my gas, you'll see here, is 1065 BTUs. We added in a heat content charge. It comes from EIA.gov. And if you go here to Ohio, which is where I'm at, and we scroll across, the average heat content for the year is 1065, and that's what I've entered on my application. So I'm going to go ahead and hit the back key and go back into measureQuick here. So now let's walk outside and let's get the meter clocked. So let me go back here and make sure I captured my gas pressure. So we're going to go into the meter clocking here. I'm just going to hit capture pressure, and now it's going to go to clock meter, and I'm going to go outside and we'll clock the meter. This is also just a good time. You can sort of stop anywhere, go back in your project, and we can hit back here. If I want to take any photo documentation like of my venting system right here, and I might get a picture of my outdoor vent. So I'm going to just add a photo camera, and this is obviously more than 12 inches above the ground. I'm going to take a look back here, make sure there's no leaves or anything back in behind. This is where the air inlet is, so that looks good. And make sure this is free blowing out, which it is. There's no bushes or anything in front of it, so that's all good there. And we'll hit use photo, and then I'm going to go back here and we'll clock our meter here. So hit home and clock the meter. So here I want to wait till the 1/2 inch dial gets to the top here where I can see it go. When it crosses the top, I'm going to hit start. We got to let that go around for two revolutions. It's a 1/2 cubic foot dial, so it's got to go around 2 times before we stop the meter. Also, pay attention to things like what your flue gas smells like. It should smell sort of like a dryer running or something like that. It should not have a acidy smell to it. That's usually a really good indicator that you have a lot of carbon monoxide. They're called aldehydes of gas. And so obviously we don't want to breathe in flue gas, but if you catch a whiff of it going past, it'll tell you a lot about how that appliance is actually running, especially if it's running very poorly. If you've ever run across one, you'll find that. Well, stop. And so now I've got my input here at 90,778. So my target manifold pressure is 3.52 inches. So we'll go ahead and we'll go in the office here in the shop. So the target manifold pressure looks good. We're at 90,651. I'm not even going to mess with it because 90,000 is the input. It's pretty much right on the money. So I'm going to go ahead and hit capture pressure here. And then I'm going to go through and take a look at my combustion readings. So again, I'm going to go back in here, put my probe in the stack, touch the back, pull it back about halfway, go to combustion measurements, and I do have to go in and connect my analyzer because I lost connection out there. So just go in the app and reconnect it, home, combustion measurements, and we'll start the analyzer. So now this is going to pull all the readings in from the analyzer, and we're going to look at our CO, O2, combustion air, stack temp, CO air free. You'll notice some readings don't calculate right away, and that's because the analyzer has to get it into range before they start calculating. And we really just got to let this run for a few minutes until our stack temperature stabilizes, and that's a really good indication that things are there. Now you can, if you want to watch it graphically, you can just scroll over here, and stack temperature is our line in blue here. I can just restart the trends because they're started from the very beginning of time since we started this. And then this will just start graphing our stack temperature on the top. But when because the furnace has been running, really all we're waiting for is the analyzer to stabilize. The furnace is already pretty well stabilized, and that's one of the nice things about using measureQuick to do this testing. So you can see our excess air is still dropping on this. Our combustion is still rising, so we're going to give this just a couple of minutes before we pull in our readings on the appliance. All right, so you can see our stack temperature stabilized out, our excess air reading stable, and this is a pretty good indication that the appliance is ready to do our combustion testing. So I'm going to go back in here, I'll go back into the flame and combustion measurements, and then I can look at all my readings coming in here. Everything looks good. I'm going to capture my values and then hit submit. Now I'm going to scroll through these real quick, and I can see my CO's in a safe range, and CO air free, combustion efficiency looks good, excess air. Combustion air temperature is a little warm because we're pulling air in from the room instead of from the outside. Tap this over, my O2's at 7.7, CO2's at 7.5. All those readings look good on the analyzer. And now we're really ready to just take our electrical measurements, and we can get this job wrapped up. So let's go ahead and we'll get our electrical readings, and then we'll get ready to print our report. All right, so now we're going to go ahead and fly through the electrical measurements. We really made this quite easy. I'm going to go ahead and get the fan watt draw first. So what I'm going to do here is just connect to incoming power, and I'll get that so it's on there good. And then I'm going to just connect down here to that little lead that I put on earlier so I could measure my, my watt draw. And then I'm going to go up here and just grab a neutral wire in my box. So now what this is going to give me, when I look at my app here, is I have incoming voltage I can capture. I can capture my indoor fan amps, my indoor fan watts. And now I can take this off here, and you'll notice that I'm going to move this from kW over to voltage now. And now I can measure my incoming, I got my incoming voltage, so I'm going to get my low voltage now. Well, let's do this first. So we'll leave this on here for just a minute. And I'm going to move over here, and inside here, let me just turn on this light so you guys can see. Inside here is a limit control in the back. So I just stand this Larry light up here, and if I reach back in here and I get on this stat here, what you're going to see is that my polarity here is showing 95.5 volts. So I'm going to go ahead and capture that, and I'm going to go ahead and start recording the screen for you just so you can use it. All right, so now I've got in my polarity voltage. The last thing I got to do here is capture my low voltage. So I'm just going to take this off this door switch, grab a ground wire. I'm going to go back to this low voltage connection here again. And I have my 24 volts. So I've got that, and now I'm going to grab here my combustion blower amps. Let's pull this off, wrap this around my combustion blower. I've got that at about point. Hold on, we'll get it over to amps, it'll work better. There we go, 0.60. So we got that. Then the last thing I want to grab here is my flame rod current. I'm just going to manually enter that, and we're at 12 microamps DC. So now I hit submit, and I've got all my data in. And let's go back here. I'm going to grab a set of combustion measurements, see if I've got those just before I print my report. And I'll go ahead and print the report. I just must not have hit capture value here. So anything you skip or you miss, you can re-grab pretty quickly here. I just realized it didn't have them in there, so we'll give this just a second to stabilize, and we'll get those final readings in. Again, we're just waiting for the analyzer to stabilize, not the furnace, so it'll stabilize pretty quickly. All right, we got our values captured, submit, and then I'm going to go in here, project, temperature measurements, grab those, hit submit, save the data, view, and hit share. Now I notice here I'm failing on a subsystem review, and it's because my total external static pressure is at 0.7 inches, which is just above the threshold on here for this appliance. Probably if I change the filters, that'll do it. I'm going to override that. Everything else looks good on there. I'm going to hit submit and share, export PDF, and we'll generate that PDF. Now here you'll notice that all my corrective actions, I didn't say what I've done yet, so let's go and we'll do that also. So back in the project and corrective actions, I'm just going to put down what I did. So on the control system, we did level the thermostat, verified our setback program. Electrical, I checked my ground, I verified my single circuit, verified my feed size, got my line to low voltage polarity, my air distribution system. There was nothing that I needed to do there, so all that's good. Air filtration is good on there, nothing to do there. Condensate drain, we did fill the trap with water, and then let's see here, verified adequate clearance to service and combustibles, so that was good. Venting system, we verified proper size, pitch, support, termination, verified it's 12 inches above the snow, verified that there's no vent system or blockages. And then our CAS zone, we did test it for acceptable pressurization limits. And also on our heat exchanger, we verified there's no flame disruption, no cracks. And then we, let's say here, inspected the secondary. Fuel delivery, we did check for fuel gas leaks and verified burner alignment, verified combustion. And then our safety system, we verified our ambient CO levels and tested our high limit. Tested our pressure switch cutout, which we can just test to make sure the switch cuts out. You can just disconnect it here. And so that does cut out. We'll go ahead and reconnect our switch. All right. We did clean the flame rod earlier. This heating operation is good. No issues to resolve on here. Operation satisfactory. The CO is below 100 parts per million. And we're good to go. We'll hit submit. We'll view the report. And now we'll have, when we share this, export this PDF, we'll get on here a complete set of readings. We get all of our pass fails on here, so you can just sort of zoom in on here and pass fails, and all of our corrective actions on the report, as well as all our photos. So that's all done. And if I want to share this and print it to the measureQuick printer, the printer's on, so I'm just going to hit print to measureQuick printer. And that'll real quickly print me out a copy of this. And I can put this up on here for the next year. And I'm using a thermal paper that's actually got a sticky back on it. They make different kinds of it, but this one's got a sticky back, and I can't remember where I even got it from, but it allows me to just stick the reports on the furnace, or you can leave them coil up inside the furnace case. But that's pretty much it. It actually is a full documentation report, all your pass fails, all of the information you need, and it's very quick and easy to do, and hope you guys love this workflow. We've got great feedback so far. This is Jim with measureQuick. Thanks a lot for watching. All right, so now that we removed all the meters, got the manometers off, and we got the furnace all buttoned up again, because I adjusted the fuel pressure on this furnace, I really need to do one more combustion test with the blower door on. Remember, this appliance is getting its air from outside, so we want to make sure that when the door's on, it doesn't affect the combustion efficiency. And again, this goes back to testing the venting system. So if there's like leaves in the outdoor vent and I had the door off, I would never detect that there's a combustion problem until I put this door back on. And then I can see how things are at. And right now we're back, we're still at the same CO, same O2. Things really didn't change that much, so it's all looking good. But this is just a good last test before we wrap everything up to make sure that the furnace is firing properly with the door on. And that's really all there is to it, and we'll get everything wrapped up.